Miklos, you too. Amazing. Marty, are we all good? Yep, perfect. So, hi, welcome everybody. My name is Anna Tudors. I work at the C3 Foundation, and I'm the main coordinator of the Shape Your World Under 19 freestyle computing competition. But more importantly, I will also be your host today. Together with our partners from Germany and Austria, we wanted to create a special creative challenge, workshop series, project, whatever you want to call it, and invite anyone under 19 years to take part. Today is the starting point, the kickoff event, but what I wanted to go a bit more about what is this I am not a robot thing anyway. While this is an international challenge aimed at experimenting with AI through exploring the limits of humanness and robotness. So during the creative challenge, participants will discuss what are the main differences between us and algorithms, and how can we reveal AI technologies in our everyday lives and also make a little bit of fun of them or even use them as creative tools. So to give you a bit of an input to show you how interesting this topic is, we invited 3 presenters today, all professionals who can tell you all about artificial intelligence. You can pose them questions in the chat, or after their presentations, you can also ask them. The first half of the event is streamed live, so please mute yourselves if you're not speaking, of course. And in the second part, there will be a workshop for registered young participants, and we'll answer all questions about the creative challenge. But first, let us introduce ourselves, the organizers, starting with Create Your World from Austria.
Hello, everybody. My name is Hans-Christian Merten. I'm the head of Create Your World from Ars Electronica here in Linz in Austria. And we are very happy to create this project together with our partners. And we are so excited about the possible outcome of this project. And it's, so to say, the next step of the project already will be the Ars Electronica Festival, which will be at from 8th to 12th of September this year, hosted online as well as on site. So it will be, again, a hybrid format we will present, where we invite artists from all over the world to think about future processes in the world, and of course also facing this small technology called artificial intelligence. And we are really excited about your thoughts. What is artificial intelligence to you? How do you recognize it in your everyday life, for instance? And yeah, we are really excited to start this project already now, together with our partners and you, of course. And yeah, that's what we are doing here. And maybe let me shortly also introduce my lovely colleague Marion Friedl. She's also part of Create Your World here in Linz in Austria. Maybe you can say just a few words that you also can be seen.
I'm here. Hello. Also really excited about this. Excited about people who want to work on this topic together, of course. And yeah, very brief hello from my side.
Super great. Thank you.
Thank you, Hans-Christian and Marion. I'll give the word to MB21 from Germany.
Yeah, hello everybody from Germany. I'm Hannes Günterroth from the Deutscher Multimedia Preis MW21, English. It's a competition that that lasts since I guess 23 years now, and it's a competition that is open for youngsters and young professionals up to the age of 25. And with this competition, we would like to motivate young people to use media in a reflective and creative way, and try to put them together to collaborate. And that's why we are in this collaboration, in this international cooperation with the other competitions. And yeah, I'm very excited too what is the outcome today, and what you might get as an output of this whole project. And we have great speakers today, great experts. You will see, and I want to thank Anna for all the organization in the background today, and and wish you all a nice input today.
Thanks, Hannes. That's very nice. Last but not least, we should also introduce C3 Foundation. So I ask CEO Miklos to say a few words.
Good afternoon for everybody. I'm very happy to be here, and I'm very happy to have this event together with you. To tell the truth, I do not want to go into details in the context of C-Cube as a foundation. I should only mention that this annual event we organize dedicated to the young generation, the freestyle computing, which it is not a secret, has the model of the Ars Electronica. We were inspired around 2000, 2001, and we thought that we should make something for the Hungarian-speaking youngster as well, because though they don't know they need it, and it became one of the most important projects of C-Cube through the years. We are very lucky that we can continuously organize it in every year. It happened last year as well, despite of the pandemic situation, and it in a way had a new birth of the virtual world, and new projects were born also. So despite of the fact that everybody became slowly depressed and so on, here I can experience the opposite, and this event shows that it was only a beginning, and there is a very promising continuation, thanks to Anna and thanks to all of you who are here. I think it's enough.
Thanks, Miklos. That was great. I think after you found out who we are, let's get to it. Let's dive into this topic. So if you are ready to begin as well, I would like to introduce you the first presenter today. Her name is Dr. Anna Henschel, and I'll introduce her shortly to you. Dr. Anna Henschel is a researcher, and her research is all about how humans and robots can work together. In her job, Anna is observing how our brain reacts when we talk to robots, when we dance with them, when we ask them to help us. To be able to look into this, she studied neuropsychology and worked on projects involving human-robot interaction. She writes about this topic in academic journals and gives talks often about social robotics, science communication, and also women's careers in science, technology, engineering, and mathematics. So welcome, Anna. We're very happy to have you here and excited about your presentation.
Thank you so much for the introduction. I'm going to, thanks for the welcome. I'm going to share my screen with you, and no, this was already, sorry everyone. I am getting there. So hopefully you can see my screen. Can someone give me maybe some audio feedback because I can no longer see you?
Sure, we can see your screen.
Awesome. Okay. Yeah, thanks so much for the introduction and your very flattering words. I'm going to talk about one of my favorite subjects that I studied in my PhD, which is social robots, and I called my talk provocatively today, How Smart Are Social Robots? Yeah, so just again, hello, I'm Anna, and we already mentioned this, but I started my career in science with a bachelor's degree in psychology. And at the time, I was getting really interested in especially the neuroscience side of psychology. So I decided to go for a master's degree in the Netherlands, which was really inspirational and super fun. And as part of this master's degree, I had the opportunity to work at the Netherlands Institute for Neuroscience. And there I really got into this topic of how the processes govern our interactions with other people. So what kind of happens in the brain if you experience someone else getting an injury. So I was particularly interested in empathy. And then kind of through this internship that I did there, I got curious about how all of these processes happen when we talk and interact with robots. And I got really lucky that there was a PhD advertised, and I moved to Scotland, to Glasgow. And here you can actually see the product of my work of the last 3 years, which I just finished in the last winter and defended my thesis. Yeah, so this is kind of my background, and I'm going to talk to you a little bit more about the research that I undertook in my PhD, and also give you kind of a little bit of an idea why I'm so fascinated with this topic. And then I'm also looking really forward to hearing what the other speakers' perspectives are, and especially also I'm really curious to see what you're going to do with all of these inputs today. I thought it would also be maybe fun to just kind of say what is my favorite robot. And despite working with a lot of robots over the last few years, I think it's still a fictional robot. So I don't know if you ever heard of The Hitchhiker's Guide to the Galaxy, but it features this super charming yet somewhat depressed robot Marvin. And yeah, if you haven't seen this movie or read the book, it's really super funny, and I can strongly recommend it. But yeah, this is still to this day one of my favorite robots ever. So I have to say, I really love the topic of the meeting today, because every other day or so when I'm signing up for an email list or I want to sign up for an event, I have to tick this little box and say, I'm definitely not a robot. And every time, I don't know how you feel about it, but every time this happens to me, it kind of triggers this small existential crisis, and I'm like, oh God, and then sometimes it gets rejected and I'm redirected to another site and I need to solve a little picture puzzle. And I was starting to think a lot about these CAPTCHAs, and I learned some surprising facts when I was looking into this. And in fact, what happens here when you see this little box and you tick it, this is only just a little decoy, and what is actually happening is that your behavior online has been already tracked by Google and has already been analyzed, and there is then a certain risk calculated that you're either a bot or a human. And depending on how high or low this risk is, they give you additional challenges to solve to prove your humanity. And yeah, I just really love this concept, and I thought I want to ask you this question, kind of spinning from this challenge to ask you what do you think makes us human? I know this is a big question, but you can answer it maybe with a small little thing. And if you want, you can head to this link that I put here. If you respond, it will be completely anonymous, and the data is also deleted afterwards. However, I am going to try and share the response screen, so bear with me while I'm switching to the other screen, and maybe the other organizers can share the link to get there in the chat. Yeah. Sorry for the little break. So just as a reminder, I asked the question, the small little question, what makes us human? And hopefully you can see the response screen now. So I think if there's no immediate responses, I will just move back to my presentation, but I thought it might be fun to ask this question. I will just give you a small moment to respond if you want. Empathy, okay, I just talked a little bit about empathy. Biology is a good one. Smiles, dreams, oh, this is so cool. I'm a little bit sad that I have to delete this afterwards again. Okay, so keep these in mind, especially the smiles. Oh, stupid. B, anger. Okay, so some like emotions, social. Yeah, that's a good word. I'm always really scared when I ask these questions that no one is going to answer. So thanks for playing along. That's really nice of you. Suppose organic being, I suppose. Okay. What makes us human? Okay. Interesting. Cool. Bear with me while I switch back to the other slide. Okay. Sorry, I just always take a few seconds to go back and forth. Thank you for your patience. Here we go. Okay, so there were some really interesting answers that you gave me about emotions mostly, and yeah, this is going to be relevant again, so keep it in mind. To explain a little bit about what these captchas actually are, and how we have thought about humanity in the context of artificial intelligence in the past, I want to remind you of the Turing test, which is really super famously named after Alan Turing. And very simply put, what is happening in the Turing test is that a human questioner examines through text-based communication if the person or if the agent they are communicating with is either human or a computer. So you can see the situation here, and the Turing test is passed if the computer or the artificial intelligence manages to pass as a human. And yeah, this is a very influential and famous test. And actually what these captchas that I already talked a little bit about are doing, and what this word actually means, is completely automated public Turing tests to tell computers and humans apart. So this is all that a captcha is. It's an automated Turing test basically, but now the roles are reversed. So not the human is judging anymore the competition, but the computer is judging the competition. So the computer is trying to see whether it is interacting with a human or a computer. And interestingly, artificial intelligence is still struggling with some image classification problems. So this is still quite a popular captcha that is being used. But also humans struggle with this quite a lot. So I'm sometimes in this situation where I'm really doubting everything about my humanity because I'm failing these captchas. But let's come back to my favorite topic again, the robots. And the question is, are robots smart enough to pass the Turing test? And here you can actually see a quite smart contraption that someone built, a little robotic arms that is solving this. It's actually called a no captcha reCAPTCHA for some reasons. And this seems to suggest that the robot has successfully proven its humanity to us. But what does it actually look like? So I present to you here some little snippets from real life. And here you can see the Atlas robot, which is just completely falling apart here at a task of putting a box somewhere. And then you can see here the Pepper robot, which is one of the first kind of big commercially produced humanoid robots that you can actually purchase. However, I would advise you to really think closely about whether or not you want to buy this robot, because it costs approximately as much as a small car, and maybe you would prefer to invest your money in another thing. But anyways, here it's kind of having the most awkward social interaction that you could possibly imagine having. You can see here the little sibling of Pepper, which is the Now robot. And in this case, it's just kind of struggling with a carpet. So this is also something to keep in mind as a researcher who's working with social robots. And these are just a few examples, but there are so many that I could have shown you. And in these years of working together with robots, I've seen really quite a lot of things, from robot motors overheating, or, you know, like several pre-pandemic, when several people were in a room together and the robot was not able to identify who it was talking to. So there are quite a lot of issues here. So I think if we're coming back to our question, are robots smart enough to pass the Turing test? I think at the moment, at least, I would say probably not right now. As a scientist, you're always a little bit hesitant to speculate about the future, but we can assume, or we are seeing, or what we are observing at the moment, and what I'm sure you're reading in the news every day, or are maybe reading on social media, is that there are so many new advances in AI, in artificial intelligence, and so the different fields of artificial intelligence, for example, the computer vision that I mentioned before. But robots are still struggling with something that is extremely natural and very intuitive to us, which is social skills. So I think this is one of the most fundamentally beautiful things that I learned in my PhD, is that really the social interactions that we carry out in our everyday life are so complex and so beautiful, and they are so small scale, and oftentimes we are a little bit like fish in water, you know. We don't notice that something is going super well until it breaks down. So if you again imagine pre-pandemic times, when someone was maybe approaching you and they were not respecting your little personal space bubble, or if someone doesn't want to make eye contact, these are little things when the social interactions can fall apart. Or imagine like you're in the situation like the robot, and you're trying to give someone a high five, and it just, yeah, it falls apart. And I can feel this viscerally if I think about that. I'm sure you have experienced that as well. And all this is to say that social interaction is a really complex problem for robots, and we're still kind of far away from solving this. So I realize that I talk now a lot about what are social robots without really kind of defining them. So I want to show you one little guy that is Cosmo right here, where he's just roaming around exploring my messy desk. I'm not sure if you can hear him, but he's making some like sounds along the way. Yeah, and so this is one of the little social robots. On the left, you can see that I was actually able to take him home with me, and this is already kind of at the end of my PhD. My professor, I think, was feeling a little bit sorry for me that I spent so many hours alone writing in my room, and she said, oh, you know, you can take the robot home with you. And this was very interesting for me as a researcher who has been for years observing how people interact with robots, to then take the robot home and become, you know, the subject of my own study. And actually what I noticed was something that is also quite a big problem in social robotics, and that quite a lot of startups that are trying to break into this robotics production are facing, which is that it's really hard for social robots to capture and keep our attention for quite a long time. So I noticed that I played a lot with this little Cosmo in the beginning. One of the nice features about it is that it has face detection, and that it actually manages to remember your face and even sometimes tries to say your name. But then, of course, its behaviors feel somewhat repetitive after a while, and it gets maybe a little bit boring. And this is one of the huge issues in social robotics that we have also not yet solved. How can we continue to predict this and keep up people's interest in these social robots? Coming back to your definitions, what you have responded earlier when I asked you what makes us actually human, there are also so many definitions of social robots, but I picked this one out because I really like that it touches upon some central points, which is social robots to some extent either have or simulate emotions. So you saw the little Cosmo robot that was kind of happily exploring the desk. They should have some communication skills, whether this is, just through the little sounds that the robot emitted or other things. They should be able to form relationships, and they should have gestures and facial expressions. And this is a really crucial point, they should have social competency. And this sort of implies also that the social robots are intelligent and somewhat autonomous. And all of these points that I just named about the gestures and the facial expressions also means that they have a body. So they are interacting with the physical world, which makes them a little bit different from, like your Alexa or Siri or your chatbots that you interact with online, which of course has some consequences for the interaction as well. So in the pandemic, we have noticed robots a lot, and I apologize for the German in this newspaper article, but I just kind of kept these as they were coming up last year. This is a robot that was used in a supermarket to remind shoppers of the new hygiene rules which back then we didn't know so well about. This is one of the Boston Dynamics robots that they used in Singapore to remind people who were visiting a park to keep social distancing. And this is a really funny article that I also really recommend about Marty, which is a supermarket robot, and the supermarket employees got really annoyed with him and put him actually in the parking lot because they didn't want to deal with him anymore. So these are some examples of how robots have been used in the pandemic, but there are also some larger societal issues where we could possibly benefit from the support of social robots. So one of these aspects is in supporting the elderly population or keeping them maybe entertained. There's a little bit of research that seems to suggest that this particular really adorable seal robot gets people in the elderly care home to talk more amongst each other, especially when they're already quite withdrawn due to some diseases like maybe Alzheimer's. Then there are this is a quite terrifying looking robot which is supposed to help young children who are struggling with social skills deficits. So this is a big avenue of research that is currently investigated, but of course still quite new. And then this is also one field of research that I personally feel really excited about. So here you can see Maya Matarik, who is also a professor in social robotics, and she is demonstrating these rehabilitation exercises. So her research is looking at socially assistive robots that can accompany you at home and motivate you to keep up some exercises, for example, if you're recovering from stroke. So as a researcher, of course, we want to know how do we perceive social robots. And here you can see actually one of my interns who was kind enough to pose in this photo shoot for me, and she's wearing a mobile brain imaging system and talking to the Now robot. And so, yeah, this is kind of one of the big questions that we asked in our research about what happens in your brain when you talk to a robot. And I also want to draw your attention to the reference in the bottom right corner. If you want to read more about it, there's an article that you can check out in your own time. So what do we know so far? And I just tried to summarize this in really broad points because there's not a lot of time today, but just to give you an idea of what we know. So what we tend to find is that even humanoid robots with faces and bodies that remind us of human shapes are perceived as objects rather than humans. Of course, this is not true for absolutely everybody. What you can actually see here in the GIF that I copied in the slide is a little girl called Reina who is mistaking a water cooler for a robot, and she seems quite enthusiastic. And this is also another thing that research seems to find, which is that young people are a little bit more open and more welcoming to imagining a life together with social robots, which of course is quite exciting to think about. So in general, we're still figuring out which traits of the robot lead to better social interactions. So does it need to show more emotion? Does it maybe need to make some mistakes? Does it need to apologize or make some jokes? to figure out if we can actually get close to what we know about these human interaction-like patterns in the brain. So kind of the brain regions that are supporting human-human interaction. And I see we're already running a little bit, I'm running a little bit behind, but I just want to finish with this quote that I really like from one of the, how do you say, like the grandfathers of science fiction. And he said back in 1982 in one of his books, "One thing we can be sure of, robots are changing the world and driving it in directions we cannot clearly foresee." And I included this follow-up question here in case we had more time, asking you what kind of useful future scenarios you can imagine with social robots, knowing what you know now after all of my input. But if you want, you can write your ideas in the chat, or you can also get in touch with me if you want and follow up, or yeah, you can just continue to think about it if you like. And I want to finish with a little picture of Marvin, and I hope that the talk was not worse than you thought it would be. And yeah, please keep in touch, and thank you so much for giving me your attention.
Thank you, Anna. This was really good. And actually, we're not out of time or anything. So maybe we can talk about that last question that you posed. And if you could maybe put in the chat, actually, that would be brilliant, so that participants can think about it. But until then, I wanted to ask you, everybody else, if you have questions for Anna, if there were some points of the presentation that you would like to go deeper into, if there was something that you specifically liked. I, for example, found this thing with Cosmo, your studying robot, quite intriguing, and also that you said that actually after a while you just lose interest. It's not that exciting anymore. And I was wondering what kind of functions it could have that would keep your attention a little longer, even if it keeps you a little bit from doing your homework.
I think this is really the big question, I guess. And one of the things that I looked at in my PhD was a small little tiny feature that we have in our everyday interactions with each other, which is movement. So even in conversation, we have these gestures, and we sometimes accidentally or intentionally synchronize our movements or our facial expressions. So maybe you know the phenomenon if someone is yawning in the room and everyone else starts yawning. So this is, some researchers suggest that this is really importantly the social glue that holds society together, which I wouldn't necessarily say, but it is quite an important feature of human interaction. So what I tried to do was to make robots synchronize with my participants, and then see if the participants in my studies enjoyed talking to a robot more if it was synchronizing with them, compared to participants that experienced a robot that was not synchronizing their movements with them. And to do that, I gave them a little drawing task, which was really quite a simple task, and then asked them afterwards, okay, what do you think about this robot? And also I gave them the opportunity to spend more time with the robot. And then I just watched and saw what happened. And what I would have expected based on what we know about how humans interact with each other, and based on this theory, was that the synchronous robot would have been more preferred. But what we actually saw was that there was absolutely no difference, and people even came in and already had such a strong positive perception of this robot, which was the Pepper robot, and thought it was super cute. And almost everyone in this sample of participants wanted to spend time with it. So there was already this quite strong positive reaction to the robot. And what this study suggests is that these mechanisms that we know of in human-human interactions might not translate one-to-one to human-robot interactions. And this is the challenge, to figure out which features that we know of can we implement in these robots so that they actually become more interesting to us, and then also serve these goals that I introduced. Yeah, so I talked for quite a long time, but I'm I got excited about the question. Thank you.
No, it's quite funny that you wouldn't think that being able to yawn is one of the most important things for a robot to do, and then here we are, proving that it is very important. Ooh, we have some interesting responses in the chat. I'll read them out loud so that stream viewers can also hear them. I think David thinks that robot teachers would be interesting. I think there are already examples of that probably, but maybe Anna knows better.
Yeah, I think you're totally right. There are already robot teachers, and I think they are experimenting also with sending robots to like remote locations and then having kind of a televised teacher on the screen where the face of the robot would be. So there's lots of stuff going on with that. That's just maybe not mainstream enough yet.
I guess it's the same pattern as the instructor for the sports exercises, where you can kind of like, you don't need a person to show something, you can just copy a robot kind of thing. Yeah. But I guess when you have questions, the robot will be less likely to be able to answer them.
Yeah, indeed. And also maybe, I mean, it's always easy to talk about it like that, but it's always another story being actually the student who suddenly has a robot in front of them. And so maybe some students would find that interesting and fun, and maybe other students would just think it's like the silliest thing ever. So it's also like a matter of personal differences again.
Okay, we have one more idea from Hanna Regina. Maybe one day we could even have a robot president. Oh, that's with a question mark. I mean, they might lack social skills, but they are based on patterns and are not taken over by emotions. So they could make good politicians. That's the scenario I thought of.
I love this suggestion. Thank you so much, Hannah. This is really something to take away and think about, especially in our current I guess, global political climate. So I think there are lots of things in this question and in this suggestion that you made. So I guess there is some issue with how who is behind the social skills and who's behind designing the behavior of the robot, because it's always humans, right? So unless we really get this strong artificial intelligence, whatever that means, in the future, there will be anyways the human kind of emotion or the human bias maybe that is coming through. So yeah, I think it would be an interesting thing to try out. And I think I even remember the name of an artist who came up with like an artificial intelligent politician. Maybe Anna, you also remember it, but I don't have the name off the top of my head, but I will go into thinking about it and then maybe I can post it in the chat later if you want to look it up.
I think it was a persona of a cat president.
Yeah.
Who was an artificial intelligence. I remember it as well, but I don't remember the name of the artist.
I'll look it up. But yeah, it's a really interesting idea. Thanks, Hannah.
Hannes is saying that probably there will be a huge opportunity helping out in social loneliness. That's again something that your research has touched upon, Anna.
Yeah, so this is a huge issue, of course, and it has become even more urgent in the last year, and it's especially young people who report increased levels of loneliness, and students who are transitioning to college or whatever and don't meet their classmates and all of these issues. So this is a huge avenue for social robots, and again, it will be a challenge for the people who are designing and programming the social robots to build them in such a way and to program them in such a way that these robots can actually sustain the attention of the user and actually cheer them up. But I think, Hannes, to your point there, just today I saw a news report on this, not a social robot, but related technology, which is this chatbot app called Replika. And there are some kind of individual anecdotal reports that that people are really building personal relationships to the chatbot, which is of course interesting, but also maybe a little bit yeah, not scary, but like it is a little bit of a development that maybe we should keep thinking about, and that especially ethicists should keep thinking about, and what happens in the future if the chatbots and if the social robots are becoming a little bit more sociable, and we do want to spend more time with them. What does that imply for our society? Which is a non-answer, but thanks anyways, Hannes. Oh, Anna, I think you're still on mute.
It wasn't a question anyway, so I think that's totally fine. It was more like an answer to your question, but still the offer stands. If you have questions for Anna, you can put them in the chat or raise your hands, and you can also ask it live. But I wanted to ask Anna to go a bit more into this thing that you mentioned when we were talking about the potentials of the robot president, about bias, because maybe some of the people here aren't familiar what that means in artificial intelligence.
Yeah, of course. So this is a huge topic, and it's not, of course, my research focus, but I guess I'm hyper aware of it. Especially as a woman in science, you are. So what it means essentially is that when you're programming a robot to do something, you are going to program it with based on your own understanding of the world. And if your understanding of the world is informed by a predominantly white male society, then the behaviors of the algorithm that you're programming, or maybe the design of the robot that you're imagining, will be shaped by this understanding of the world. So we need to be really careful when we are letting loose these algorithms and always consider potential bias that could go into these designs and these behaviors. And this is especially important for any kind of computer vision based algorithms that are out there. But I think it's generally a super important concept to keep in mind when you're thinking about human robot interactions and everything beyond.
Thanks. That's I think that's a quite important point. I'm wondering if there's any other questions from the audience, maybe. Maybe some other future scenarios, because otherwise okay, we have a question. So Hanna Regina wanted to ask about robots making robots. As you mentioned, the creators behind algorithms, and yes, women in science rule. Well, we agree with that.
Yeah, I think we agree, Hanna. And very meta. I think one of the later talks maybe is talking about robot dreams. But yeah, what happens when robots finally become independent of of us holding them back? At the moment, really, it is. I wish at this point I could show you again all of these fails that I've experienced with robots over the last few years. I'm really not the least bit scared of robots suddenly producing more and different robots. But I just saw that a really exciting guest entered the chat. So I think this is exactly the right moment to give the word over and say thank you for your attention.
Thank you, Anna. And hi, Yoshaba. We're really happy that you could join us. I will introduce you to the rest of the group who might not be familiar with you just now. Joscha Bach is a scientist and an AI researcher with a focus on how computational models of cognition. Oh, sorry, I have a typo in my bio, sorry. Anyway, Joscha is looking into how humans and machines process information, very simplified, but he will go into that, I'm sure. He has taught and worked in AI research at various universities, science centers, media labs, and he's currently a principal AI researcher at Intel Labs in California. So it's very early morning for him. We really appreciate that you're here with us today, despite. Yours was mainly interested in using the methods and perspective of artificial intelligence to understand the nature of minds and their relationship to reality. So you didn't hear it, but you will have a chance to listen to it later on. I think it's a very good follow-up presentation to Anna's lecture as well, and we're very excited to hear what you have for us.
Thank you. I share my screen, or should I just not use slides? What works better?
You can share your screen if you would like, sure.
So hello to everyone from California. Does this work all right? Can you see my screen and me? And
we see the presentation slides on the left still, but we see the main ones as well.
Oh, let's see.
This is a little better.
Yes, but it's not what I want. This is not it's not only the slides, right? You see the presentation mode?
We see presentation.
You see only my presentation?
No, we see the presentation mode.
Okay, so everything is good now.
Well, we don't see the presentation in full screen. We still see stuff.
Okay, that's unfortunate. Let's do something else then. Let me just share my entire screen then. And maybe this works.
This is perfect, actually.
Okay. So my perspective, philosophy is the land of all theories that exist. And philosophy is conducted in natural language and is based on human understanding. And it's one of the big intellectual root nodes that we have when we want to understand reality. Mathematics, on the other hand, is the domain of all languages. And it starts out with the simple languages, with those that you can formalize. So it starts out with logic and numbers and shape and space. And it's very difficult to say something that is true and provable in philosophy because the languages that we use to make sense of the world are so vague. And many of the words are not properly defined. And on the other hand, it is very difficult to say something very meaningful about the world in mathematics, because mathematical languages are so simple that it's hard to capture the reality that we are in and the relationships that we stand in with other people, with our own life, and so on in mathematical languages. And to make progress in philosophy, we now have wrapped most of the low-hanging fruits. Some say that the last breakthroughs in philosophy happened almost 100 years ago. And so to put there that we can go beyond what we can express in philosophy, we probably need to close the gap between the languages in which we can prove things and philosophy. This project is very old and, for instance, has been suggested by Leibniz, who came up with the idea that we build a calculus where we can express all ideas in a way that we can calculate whether they're true or not. And of course, back then, when he started this entire project, there was no way in which it could be executed because humans are not able to monitor the calculations that their brains are doing. And in some sense, we need to automate this process. Also, there turned out to be a problem with mathematics, as Gödel discovered last century. He discovered that you cannot build a computer, even in pure mathematics or in any kind of universe that runs all of the existing mathematics without crashing. There was a bug in the way in which mathematical languages are defined. And Alan Turing later discovered that you can make a computer that can maybe not do all of classical mathematics, but it can do all of constructive mathematics, which is computation. It turns out that the mathematics that we can use to describe reality does not contain infinities, it doesn't contain infinite loops, and some other concepts that have been introduced as artifacts of classical semantics, but computation. So basically, we can describe the world using automata, using hypothetical mathematical abstract machines that describe things as state sequences and transitions between these states. And Turing also found out that all the computers that we can build in this universe have the same power. It's the only difference between them is how much memory and speed they have. And of course, what kind of graphics card interface they have to the environment, but they all can compute the same function if you give them enough memory. And this means that everything that is a machine is in this category, and our brain is also in this category. It turns out that our brain is, as far as we can tell, based on these theories, a computational machine, and it runs on some level some code. There is some software happening, and maybe we can build computer systems that are doing the same thing. And this idea started the project of artificial intelligence. And this artificial intelligence is multiple things. For many people, artificial intelligence is just the automation of data processing. And this is the majority of what the people in my field do. But it's also the most important and most risky project that there is in philosophy. It's the idea of building a mind that is able to think about reality, to bring the languages in which we understand what something means and the languages in which we can compute truths together. And to do this, we need to understand how our mind grounds our meaning in elementary operations. Wittgenstein came back from the war, and in the trenches of the First World War, he thought about how to make philosophy better. And he wrote his ideas down when he came back in the Tractatus Logico-Philosophicus, which is a very beautiful book of something like 75 pages. It's almost like a poem. It's a philosophical book without any footnotes or any argument to convince anyone. It's just a single connected thought. And in this thought, he tries to express how to make a computer language for thinking, how to clean up the natural language in such a way that it becomes formalized. And this project is very similar to what Minsky and others tried to do more than 30 years later. And in the end of his life, Wittgenstein found that this project had failed because he doesn't know how to describe meaning in this language. And it's mostly because he didn't know how to deal with images, with perception, and with the reality that we experience in the context of computer programs. So formal grammatical languages are somewhat easy, but extending this into the world of meaning that we experience is hard. So a little bit later, one of his pupils, or one of his students, Alan Turing, came up with the idea of a Turing test in the context of a paper that he wrote in 1950. And the core of this paper, which is very readable and everybody should read it, it's quite beautiful, is can we make a computer program that passes as human? And how would we know that we succeed? And most people have heard about the Turing test or know it intimately. It's the idea that you sit on some computer terminal as a human being and you test whether something talking to you is a human or some kind of program. And if the program can successfully pass as human, you should grant it being intelligent. And I don't think that this is itself a very good condition. I think you want to do an in-depth interrogation that really checks what kind of faculties it has in the mind. And part of that is that you check whether it plays Turing tests on you, right? We do Turing tests on other people all the time. We try to find out what they understand, what they're conscious of, what they're aware of, to which degree they understand that we are minds and they are minds, and which faculties we possess, because we don't have faculties in every domain, we don't have awareness in all domains. What is a mind? I think a mind is a system that has general intelligence, and intelligence is the ability to make models. Models help us to make the right decisions and movements. And most of what we've done in artificial intelligence does not fall under the category of building minds or general intelligence. It's narrow AI. It has only one model. It can only do one thing using this model. And a general AI can make its own models. It's able to discover, to learn how to learn. And so it can solve the questions that are important to us. What is going on? What are the things that I can know? What am I? And what should I do? An important notion for me is the idea of sentience. A sentient observer has an inner world that explains what it is happening in reality right now, and it has a model of itself because that's part of its environment. And as a result of understanding its relationship to the environment that it's part of, it is capable of knowing what it's doing. Humans are clearly sentient. Many of them know what they're doing, but are cats sentient? let's look at this cat. Here you see it's a video that went around on the internet last year. And you see a toddler. What you cannot see is the toddler is going to some stairs that are very, very steep, and the toddler is about to crash down these stairs and hurt himself or herself very badly. And the family cat sees that and catches the toddler and beats the toddler back into the room to make sure that the toddler doesn't fall down the stairs. I think this is remarkable because this cat knows what it is. The cat knows what kind of abilities it has. It knows its place in the family. It sees itself as some kind of family member and has some responsibility for a family member that would fall down the stairs. So it's able to understand the intentions of that agent, of this toddler, and the capacities of that agent. And it knows that there is something in the future of that agent that it needs to intervene with to prevent something really bad from happening. And so I would say that this cat is clearly sentient. This cat knows what it is and it knows what it's doing. But the cat is probably not generally intelligent. It's not capable of understanding what a mind is, for instance. It's not capable of learning a grammatical language in the way we do. A generally intelligent agent is sentient, but it can also explain how it works. And if we are able to build a general artificial intelligence, it means we have created an artifact that demonstrates our understanding of how our own intelligence works. And before we have created this artifact, we don't really know if we are indeed generally intelligent, if we know that what intelligence is, what we are, what our deep relationship to reality is. How do we perceive reality? Right? Typically, we look at the world and we have ideas about the world and we describe this distinction about the world as in some dualist conception, as a mental domain and a physical domain. Right? Dualism proposes that there are two worlds, the world of the physical interactions and the world of the ideas. So, Descartes calls this physical world res extensa, the world of the extended things, and the mental world res cogitans, the domain or the substance of thought. And as opposed to dualism, we also have idealist traditions which say that hold that there is only a mental world, that we exist in some kind of dream world, and that reality as we perceive it is a dream that is dreamt by a mind on a higher plane of existence. And this would explain why magic is possible, why things are possible that are not compatible with physics, like consciousness, conscious agents and so on, which we cannot explain in a straightforward way using physics. And there's another intellectual tradition in philosophy, which is monist materialism, which holds there's only a physical world. And in this physical world, there are machines like our brains, and these machines are capable of producing models. And some of these models are mental models that give rise to consciousness and experience and so on. And there is a way to bring these two perspectives together, because I think that they're both incomplete. I think that both the physical world that we experience and the mental world that in which we think and reflect about that experience exist inside of our mind. They are both dreamt by a mind on a higher plane of existence, and this mind on the higher plane of existence happens to be in the skull of a primate in the physical world. The physical world is nothing that we can experience. It's just some weird quantum pattern generator that we don't have direct access to, but that projects patterns at our systemic interface. And it's our mind that creates both the mental world and the physical world as mental worlds. So in this perspective, we understand that we live in a dream that is generated by our own neocortex. And what's most interesting to me as an AI researcher is how we could build machines that generate dreams, in which they have a model of the universe that dynamically changes according to the features of the world that they're entangled with, in the same way as we are entangled via our body surface and our retinas to the world, and our brain computes functions to predict what's going to happen next on our retina and our body surface. And inside of our own models in our own brain, right, we also predict ourselves. And in this dream, that is basically generated very similar to music is generated. I think it's a good metaphor to use a synthesizer. Synthesizer is a machine that generates sounds by building a circuit of a lot of oscillators that you connect, and by fiddling with the dials of that oscillator, you can learn how to produce almost arbitrary sounds. And with a little bit of experience, you can use the synthesizer to make the patterns and sound that you want. And it's a good way to think of neurons being oscillators that are being tuned by changing the parameters of these neurons, by changing the synaptic weights between them in the way that they are addressed with by other neurons and the chemical signals that they send to each other. And you can not only use this for the sound domain, but you can also use this to represent colors and spatial frequencies. And once you extracted the low-level patterns, you can try to look for higher level patterns, for patterns in the patterns. And you might discover, and you can do this also in a synthesizer that you build up step by step, that there is a way in which you can combine the low-level patterns into higher level patterns. So for instance, you understand different sounds as being the same sound as at a different pitch, or you understand different sound sequences as being the same sequence with a different rhythm. And in this way, you can build up structure that is going in the direction of percepts. So you go from low-level features to compounds of these features that produce perceptual content already, something like textures. And then you can combine these textures into dynamic scenes. And these dynamic scenes are in some sense simulations that at a high level of abstraction represent what might be going on in the world around us. And then we can build conceptual abstractions over the scenes that we see, which basically note what is in common over the different scenes that we experience. And then we can linguistic abstractions, like words like cloud and wall and floor and so on, that we can use to label the concepts and that we can use to organize our own thoughts and to communicate our thoughts to others. And to develop thoughts that other people suggest us and build new concepts in mental simulations based on linguistic representations. It's all done via the biological neurons. And I think that we sometimes don't give them enough credit. They're like little animals that try to survive in this dark confine of the skull. And in order to survive, they have to link up and collaborate and move the organism around as a result. And if they don't do this in the right way, they will die, right? It's the only chance that they have. So they need to form an organization that processes information in the right way. But the individual neuron is not very smart and is not entangled with the world in a very rich way. It doesn't have that many signals. At best, it can receive electrical impulses from a few thousand other neurons. And there are trillions of neurons that it doesn't talk to, and there is no world that it can talk to. So it's basically like a submarine in pitch darkness that sometimes hears a ping, and then it has to decide whether to respond with its own ping. It lives in a pretty lonely existence in a very dark and lonely universe in a way. And so the only thing that it can do is learn how to fire based on which combination of pings it hears in the environment. And this, and then it checks what kind of reward it is getting. So the individual neuron is a little reinforcement learning agent that links up with the other ones in 2 units. And the basic unit in the neocortex seems to be a cortical column. And the cortical columns can connect to each other in patterns that they can assemble and disassemble like Lego bricks. Each of these cortical columns is made of a few hundred neurons. And we have something in the order of 100 million mini columns that are in some sense combining a little function approximation, a thing that can learn functions, and some message passing machinery that allows them to link up with the rest of the brain. And they are organized into areas. Each of these areas is dedicated for processing certain classes of functions, and they connect up in some kind of hierarchy, which the different cortical columns have receptive fields in the other hierarchies and project into other hierarchies. And this forms some kind of architecture for computation. Or you could see this as an orchestra with something like approximately 50 brain areas or 50 instruments. And the instruments are listening to the instruments in their neighborhood. And they are taking up the themes and melodies that they hear in the neighborhood and modify them and pass them on. And this cortical orchestra is playing a symphony that we perceive as a model of reality and ourselves and the interaction between ourselves. And this orchestra has some kind of conductor. And this conductor lives in the dorsolateral prefrontal cortex, as far as we know mostly, or this is where most of its representations are being stored. And this is an instrument like the others that is not perceiving the music of the orchestra as a whole. It's singling out a few of the instruments and listens to them and synchronizes the activity or fixes the activity and gives feedback to them. And this is the conscious attention that we have. And this conductor stores what we learn in an attentional protocol to which we can later have access, and that we allow us to generate a conscious experience. So this conductor is producing an integrated model of our attention. An important thing to understand is that we don't experience physical reality. What we experience is a trance. Whenever something appears real to you, it's a trance. It's because something in your brain trusts that something is the way that another part of the brain says so. And neurons themselves don't experience reality. Brains cannot experience reality. They're just physical mechanisms that we model in our own mind as separate units that are separate from other units and that interact. And in order to experience a reality, the brain needs to make a model of reality and an agent that is experiencing it. The brain doesn't know what it is like to be a person, but it needs to know it. It's not a person, right? It needs to have a model of what it would be like to be a person, so it can move an organism through a world of other organisms. And for doing that, it creates an experience of that thing. And this experience is virtual. So consciousness is not a physical property of things. It's a virtual property. There are some neuroscientists which think that simulations can never be conscious. So computer programs could never be conscious. And consciousness is only a feature that real things in the physical world can have under very, very specific conditions that we don't understand. And they got it exactly backwards. Physical things cannot be conscious. Only virtual things can be conscious, because consciousness is a virtual property of a simulated system. You can only be conscious in a dream. And our brains are best understood as machines that dream. And what interests me is, how can we build systems that we entangle with reality so they can create their own dreams? And then how can we talk to them? So this is my input for today. And I hope that we have some time left for questions.
Thank you so much, Joshua. That was really, really interesting. If you have any questions, please put them in the chat, or you can also unmute yourselves and ask Joshua. But maybe I'll start for now. I was really intrigued by that video of the sentient cat and how it kind of realized a dangerous situation and recognized that there's something that it needs to do. And I was wondering if you know of any implications of or science into how the brains of animals can understand us better that can help us understand better how they perceive reality, or is it just kind of like a dumbed down version of humans?
I suspect that for the most part, it is indeed, you could say, a dumbed down version of humans. And it's dumbed down because not just because of the size of the brain of the cat versus the human brain, but because of the length of the childhood. We train our human brains in some sense layer by layer. If you have a child, you can observe how, as an infant, it changes in certain phases or periods. That is, after a few weeks, it suddenly undergoes a dramatic shift in its behavior and its experience of reality. You can see that the next layer is coming online. And the frequency at which these new layers come online is going lower and lower. So at some point, there's a big shift around 2, 2.5. Then there's another one around 5 or 6. Then you have one that is on the onset of puberty. There's one in later adolescence. There's one in your mid-30s and so on. And maybe there's another one in your 50s. And it's like there is no end to the layers that you can make to model reality. And the time that it takes for us to become an adult that is able to feed itself is very, very long compared to most other animals. A gorilla is able to move into their own home at about 1.5 or 2 years old. And a human takes something like 15 years or longer, even in ancestral environments, before they can find more food than they consume. So it's very, very expensive to have this long childhood during which you're functionally insane because you don't have a proper model of your place in reality and how to deal with reality, even though your body would be capable of doing that. It's your mind that is not capable of making sense of reality when you're young. You don't notice this because how would you, right? You don't have any checks and balances that tell you what you don't understand. And I suspect that becoming a full adult is something that even the majority of human beings don't manage to achieve, where they become aware of how they construct their own model of reality. Right? Their psychologist Robert Kegan suggests that there are crucial phases of development, and most people stay in level 3, which is where you make realities based your own reality based on what other people in the world around you think. So you form your ideas based on observing what good people think about the world, and you assimilate these ideas via empathy. And when you are in agreement with the people around you, especially high status people like your boss and your priest or your scientist or your leader, then you are good. And at stage 4, you understand that what's true is completely independent of what other people think is true. And you discover that something should only have confidence to exactly the degree that it's supported by evidence. And at this point, you get agency over your own beliefs. And at stage 5, you understand how identity is constructed, what values are, that values are generated in your mind and that they're instrumental to something that you are serving, and how you can make sense of what this is that you are serving and how other people do it and what a greater place in the world is construed to be for yourself. So at this point, you become transformative. You get freedom over what you are. And this is something that maybe only 1% of people get to, at least according to Robert Kegan. And I think that this we can have intuitions of this before we have abstract models of this. And the cat has much faster development than us because it has a much shorter childhood. And the layers of the cat come online after a relatively short amount of time. And this means that the cat does have a theory of mind. It has a model of sociality and so on. But these models are based on priors that are wired into the brain of the cat. So the cat has good intuitions of what it should explore. And because each of the phases is so much shorter, the cat sees less training data than we do. So the cat cannot form the same level of abstraction. And I think the same is probably true for the great apes. They have brains that are in a similar region already than as human brains. So gorilla brains are smaller than human brains, but there are some humans which have brains that are smaller than the brains of the largest gorillas. And they are completely capable of participating in human society and be relatively smart, right? So the difference between us and the great apes is probably mostly the length of the childhood. Could be that there are some biases that make them more interested in learning grammatical language or to perform certain tasks in the world. But I suspect that most of the capacity that we have is only the result of us spending more time learning them.
Thank you so much. We have some 15-year-olds in the audience as well, so it's definitely maybe a step forward for them to learn about all the stages. But I have some other questions that I want to read out loud so that the stream viewers can only hear them. Anna Henschel was asking, are androids dreaming of electric sheep? Or asked differently, when the AI is dreaming, will it be like something we are dreaming of? Thanks for a talk.
It depends on how you are entangled with reality, and it's unlikely that the AI is going to be connected to the world at the same level as we are in the same way. The way you perceive reality depends on what kind of reality you are bound to, and the world that you notice is one of mostly interactions with photons on your retina and with atoms that push against your skin and your eardrums. And these are electromagnetic interactions in the between the different atoms and molecules. And all these electromagnetic interactions take place in a 3-dimensional space in a certain range of time and space at which we can resolve the world. So we don't see molecules and we don't see nation states or organizations and so on, because we are not directly connected to them. We have to infer their existence. And if we build an AI, it could be, for instance, connected to the stock market and all the data sources and the entire internet, or it could be connected to all the sensors in a factory. And it would be connected at a very different timing. It would probably have a higher temporal resolution than we do. And this means that the world that it perceives is a very different one. We would not be living next to it, but maybe inside of it, right? We might be the gut flora of some of the AIs of the future. And such a system would be seeing the world from a very different perspective. By the way, also we humans form next level agents. So if you are part of a group that is very synchronized, then the group has a coherent spirit in a way. And spirit is, I think, just the old word for operating system for an autonomous robot. And this was invented before we built autonomous robots ourselves. So the only autonomous robots that were known were people and animals and plants and cities and nation states and ecosystems and so on. And then when they have coherent activity, you can describe them as having some kind of software that coordinates the parts of them. It's a pattern that you see in coordinated activity. And this, if this pattern has a direction, some agency, then we notice that there is some spirit that animates the things. It's a projection that we make to understand how something moves around in the world. And the same thing is true for us, right? There, we see each others as spirits emerging over the activity of the neurons, and only the neurons are real. And the spirit that we see in another person is a pattern that we recognize in the activity of other neurons or of other people and their interaction with the environment, or in groups of people. Anna, I cannot hear you. Okay,
yeah.
I'm muted now.
Heard it. Marion is saying that she really likes the idea you mentioned that we could in a way see human interaction also as humans doing a Turing test with each other, testing their being human. And it kind of connects to what Simone is saying here. If we stick with the cat example and imagine that the cat was a human, but it did not intervene, it wouldn't do anything to save the baby, what would that have told us about that human?
Yes, it might have told us that the human doesn't care, or that the human doesn't understand the situation. So there are two elements that go into this. One is the relevance of the situation that tells you this is this network of relationships that you're part of and that you are serving. And the other one is to which degree are you able to understand the consequences of your actions and the events in the environment.
Thanks. I think that if there are no other audience questions, I'll leave a bit of time because I think this is a topic that needs digesting and maybe ideas pop up a bit later.
You can also criticize things that I said, or say, oh, I don't get any of that, or this is nonsense, or you can ask something weird. Go ahead.
You can also unmute yourselves if you want. You don't have to write in the chat. But I think, Yusha, you're super confident, difficult to criticize. But we have a question. I always wonder how realistic the thought of AI is, transforming visual impressions into proper procedures or reactions.
Yeah, it's a very good question. For many people, the idea that we could build a machine that has experience of the world in a way similar to us, or even surpassing our abilities and skills, and maybe the depth of our conscious experience is preposterous, right? It's almost an insult to the way that we perceive ourselves. And that's maybe something that is specific to our own culture and the way that we perceive our own minds as some kind of supernatural miracle. And I wonder what it would mean if something is fully supernatural. Everything is eventually natural. Everything is nature. If you perceive a supernatural power, then something must implement and realize this supernatural power, even if it would turn out that this universe that we are in is some kind of simulation, and magic is possible in the simulation. Something must run the simulation. There must be something underneath it. the big question why there is something rather than nothing is very puzzling. Maybe everything possible exists, and we are in one of the corners of existence that might exist. But so from this perspective, the universe is some kind of machine, and we don't know what has put it there and why it exists. And we also don't know what the lowest level of that machine works. So we don't have a completely foundational theory of physics that goes far beyond quantum mechanics, or theories that would generate the phenomena that we describe in quantum mechanics. And maybe this is a puzzle for which we need to build machines, because humans are just not smart enough to solve it. But I suspect that we can solve the puzzle of how our own brain builds models of reality by building something like this mental orchestra. When you perceive the world, there are blips on your retina. That these blips are generated by photons exciting nerves in the retina. And what your brain is trying to figure out is the relationship of these blips to other blips on your retina. This is the meaning of information. Information is discernible difference. And the meaning of the information on your retina is the ability to predict other blips at different times or at the same time that are in some connection to them. And you put this together into functions in your brain, and you perceive these functions as, for instance, people moving around in a three-dimensional room while the sun shines on them and they talk to each other about ideas. So this is the kind of construction that we need our machines to make. We need to be getting to the point where we connect the camera to information processing system, and it's capable of finding an organization that allows us to make sense of the blips on the camera sensor in a similar way as we make sense of the blips on our retina.
Talking about things that we don't know, what is the biggest question currently for you in your work or research that you would absolutely love to find the answer for?
One of the questions that I find very interesting is how do perception and the symbolic mind relate? Is the symbolic mind something like a specific kind of perceptual thing that is entrained on the perceptual mind, or are they somehow using separate circuits and work according to different functional principles? And I suspect it's the former, but this interface between perception and experience is a symbolic organization is something that is deeply interesting to me. There are other puzzles, for instance, the puzzles of physics that I find very fascinating, and I feel that I'm ill-equipped to solve them. There seems to be a limit to what our human brain is doing, how many levels of meaning we can connect to each other in one integrated model and not lose track of the different ideas that we pass around in our mental model. In some sense, our brain is making simulations of the world, and we do this when we understand our own mind and when we understand physics. And at some point, these simulations become so intricate that we need to take them out of our minds and build them into computer models so we can track what's going on. And to build these computer models is very hard, so we need to have computer programs that help us building these models. So we start to automate our own thinking. And this is also something that is deeply interesting to me. How can I extend my own mind into machinery that has a fluid connection to my own mind? So I feel that still my motivation that goes is controlling all this, and it's still part of me, but it extends beyond my human brain, beyond my human capacity in a seamless way.
Sorry. Just the last question, maybe, if there's no other ones from the audience. There's a lot of talk about Generation A as algorithm and Generation COVID. I guess now we are experiencing the world through simulations, through these Zoom calls that we're in, and I'm connecting with someone in California right this second, and I would like to hear a bit more about whether you think this actually makes any difference in our perception. Do kids who grew up with these screens that channel in different sorts of realities or situations to the same place make a difference in what kind of perception they will have as grown-ups, maybe?
Definitely. I think that every generation builds their own model of reality. And a big problem is that our future is changing faster than our models of reality can track it. And this means that our civilizational hive mind has lost the plot. We don't have a very good model of the future anymore. Our projections mostly end in 2100, when we know that climate change has become so bad that we don't know how to deal with it. And we don't make projections beyond that. And most of our institutions of society do not plan further ahead than a few decades. And the pandemic has shifted this time horizon to much, much shorter. It's basically in the way which we organize our economy and make plans of the future is mostly just a couple years at the moment. So this is terrifying. And the current generation is, from our perspective, the generation X, called the generation Z, and we don't really know if something comes after that, right? It's not as if we have left a lot of letters after that. I think that in a way, the our generation, generation of World War II, still had an intellectual continuity from the previous generations, and ways in which they made sense of reality were shared. And after modernism ended, this perspective that built the big societies of the 20th century, which mostly crashed and failed, the communist societies and the fascist societies and the capitalist societies, which are all now either crashing or muddling through. This is all over now, right? And ever since, every generation has lost the plot even more and has less of a plan what to do with the futures. We might have very strong intuitions and moral movements, but we probably need to build a new idea of how to deal with reality if we want to stay around as a species. And that task is on the next generations.
Thanks, Yusha. This is actually, I think, a perfect ending point, and thank you very much for your presentation. I think now I will, before I introduce the last speaker, Simone Wallner, I would say a few words about the practicalities of this creative challenge that we've been organizing. Because it relates to what Yosha was saying, that basically it's on us how we determine the future, and especially on you guys who are taking part in this challenge. You have like this chance to contribute to it now, and Simone will be the first mentor guiding you through this process until September. So I just like to say a few sentences about what is there to know. This I Am Not a Robot challenge, we gave it this title, is inviting young people on the age of 21. They will meet once or twice per month online for about a year. So this is a long-term project, but the kind of meeting points will be decided by you as a group together. These meeting points will be introductory talks by experts on AI, just similarly to the one we have here now for the kickoff event. There will be creative workshops, games and game making, group work, mentorship, and presentation opportunities between June. So we will start in June and next January. So that is sort of like the time frame we're thinking in. The first presentation will be at the Ars Electronica Festival in Linz. That will be in September. And then we will have an event in Dresden in November and in Budapest in December. And these will coincide with relating competitions of the partner organizations. We will try to organize a get-together in the future, but obviously that would depend on a lot of things, as you know. At least I can tell you that we will try to bring you together at some point of this process, probably towards the end. The language of the challenge will be English, and it will be open for international participants, and it is free of charge. You can apply from today, and I will share my screen with you. I'll show you a link for that. So if you scan this QR code, and I'll put the link in the chat, that will lead you to a form where you can sign up to take part. In what exactly? In what exactly? That is Simon's part now for the presentation. He will be your first mentor, and he will kind of start you into this process of working together. So let me introduce him, and he will say a few words as well. So Simon studied visual computing in Vienna. Already as a student, he was passionate about games and interaction design, which became his career. So he's very experienced in organizing game jams and hackathons, and he's even teaching in Austria, helping students making their own games. So I'll give the floor to you, Simon.
Thank you very much, Anna, for the introduction. Let me just share my screen. Okay, yeah. Hi, everybody. I'm Simon. As Anna already told you, I have a background in computer science, so I kind of identify as a computer scientist, programmer, but I'm also a game designer and game developer. That's kind of my day job. So it's for me, it was a bit dream coming true, doing the thing that I like on a professional level. The picture that you see here, that's our team. We are Lost in the Garden, we're a small company who does games and interactive stuff. Fun fact, Raimond, roughly a century ago, he even won the U19 computing contest at Ars Electronica, which was in 1999. So that's gives you an idea of how old we are. Kind of our legacy spans the centuries already. So yeah. The things that we did in the past, it's coming from video games. So we did a fancy racing game on consoles, PlayStation, Xbox, and on Steam. It's called Lightfield. It was quite fun. It was the first thing it got us started as a company, and ever since then we're doing very different projects. Everything kind of mostly in the interactive games area. It's not always just games for entertainment, but also games for purpose. So making games and installations for large international companies. But we also did exhibits and so on. So it's very different things, from stuff on your mobile phone to very short games on huge soft drink vending machines, thing that says hold the button, to experiences where we have a whole room of projections and touch screens and so on, together with partner companies that then took care of the hardware and so on. Yeah, I'm very happy and excited to be here, to be your mentor for the first stint until the Ars Electronica Festival. It is pretty much my role to facilitate your journey, to be there as a guide and to help you to do pretty much whatever you want to do. This is also something that we did with the game jams. As Anna told you, I've been organizing quite a few game jams and hackathons, and we always try to construct a frame that is then there to support everybody to realize their dream and realize what they want to do. So it's it will be a bit structured, but also it's an ongoing journey also for me. So I think we will adapt and change things as we go. Also, kind of doing the remote thing is also new to me, at least in this setting. So there will be a lot of trial and error, and I'm also counting on you to help out and to create something together. A thing that I want to try to use is a little tool called GatherTown. It's kind of a social chat thing. And I'll briefly try to share the other view. Oopsie. In GatherTown, you can also kind of create your own spaces, and the idea is to create our own virtual space that you can use to converse and to meet, and also to change it and to shape it. So you can pretty much do whatever you want to the map and create whatever stuff on it. And the idea is then also to use this a bit as a presentation framework for the Ars Electronica Festival, where then visitors are coming into your space or into our space, and there you can also present your work and your you see that then we can then kind of do, instead of going to Teams or Slack or whatever, then we can use GatherTown to for your own meetups and to change the space around us. So the idea is to also have kind of a meeting space and the space to create our own that we can then use to come up with cool projects, cool ideas, and to cooperate. It's kind of the next best thing we think that we have instead of meeting in person, which would be much better, of course. But yeah, in this day and age, I think that's the best we can do. Yeah, so that's the rough intro and kind of the plan until the Ars Electronica Festival. And now it's back to Anna.
Thanks, Simon. Yeah, so I think that was the first part of the event. I hope that we kind of got you excited about this as well. Thank you for all the amazing presenters. We've really thoroughly enjoyed your presentations, and hope that you can also take something into the workshop from them. It was really great to hear all about your work. And I'm afraid that I will now have to ask everyone who would like to come to the short workshop or brainstorming session to stay in the call. So don't leave. This will transform into a workshop space, and Simon will take it from here. And all the others, thank you for being here with us tonight, and you are free to go. A few more things before we end the stream, though. I forgot to mention, for anyone who's interested in the challenge but isn't here. Oh. Hi, Anna. I was just saying that we reached the end of the first part of the session, so we will kind of say goodbye to all the presenters. But before we do that, I would like to say that whoever is interested in the challenge but couldn't make it today, but is watching this stream later on, please register on the link that I sent earlier. Our first meeting will be on the 2nd of June, and hopefully we don't have to say no to anyone. We are planning to take 5-6 participants into this project from each country, so that there's a really nice mixed group of young people working together. So that is the plan. Thank you everyone for being here, and that is the end of our streamed session.